Welcome to Lesson 10, the final advanced stage before this series turns honest about systems limits. Here's the premise. Most services start at boot whether anyone uses them or not. That's wasted RAM, wasted CPU, wasted boot time. Socket activation and path units flip the model. Ports stay open, files trigger work, and idle services simply don't exist. If it isn't used for 5 minutes, it shouldn't be running. So why bother? 4 concrete wins. 1. Boot parallelizes. Because Service B no longer waits for A to be ready, it just opens its socket and dependency graphs collapse. 2. Idle means 0. A service handling 5 connections a day stops burning RAM for the other 23 hours. 3. Restarts don't drop connections, since systemd, not the service, owns the listener. And 4. Crashes self-heal. The next connection simply wakes a fresh instance. No load balancer choreography required. Let's watch it happen. At T0 and T1, systemd binds port 22 and starts listening. Service itself isn't even loaded. T2, a client connects. The kernel's accept queue holds the connection. T3, systemd fork plus execs the service. T4, it hands the already open socket across as file descriptor 3 via the listen FDS environment contract. T5, the service takes over and serves. The client never noticed the cold start. Now to the unit files themselves. A.socket declares what to listen on. A pair.service does the actual work. Same naming pattern you saw with timers back in Lesson 7. Listen stream equals 22 binds the port. Accept equals yes spawns 1 templated SSH at instance per connection, which is why the service file uses the AT symbol form. Standard input equals socket is the magic line. That's what hands the file descriptor down to SSHD. Enable the socket, never the service. Systemd takes it from there. That accept setting deserves a deeper look, because picking the wrong flavor bites you later. Accept equals yes is init reborn. 1 connection spawns 1 service instance, perfect for low-traffic stateless things like SSH, where isolation per connection is a feature. Accept equals no is the modern default. The service starts once and handles every connection itself, which is what you want for NGINX databases, anything with its own connection management. Get this backwards and you'll see resource exhaustion on one side, or lost isolation on the other. Sockets handle network triggers. Path units do the same thing for the file system. You get 4 flavors. Path exists, and path exists glob fire while something is there. Path changed fires on close after write, perfect for config reloads, and path modified fires on any write at all. The CSV importer below is the canonical pattern. A path unit watches a spool directory, and the moment a file lands, a one-shot service processes it. And remember, you enable the .path, not the service. Rule of thumb. Path changed for configs, path exists glob for queues. 3 patterns worth burning into memory. First, socket activation at boot. Postgres, Nginx, your app. All 3 sockets bind in parallel at T0, services start when traffic actually arrives, and a 30-second boot collapses to 5. Second, a path unit on your config file calls a reload service that sends PSYOP. Ansible writes the file, the reload just happens. Third, path exists glob on a spool directory drives a one-shot importer. No polling, no cron, no while true sleep 60 bash loop, event-driven end-to-end. Step back from the patterns and look at why this matters. 3 principles. 1. Lazy beats eager. Eager loading is lazy authoring, but lazy loading is lazy operating, and 100 services idle for 23 hours a day is 2,300 wasted instance hours every day across your fleet. 2. Events are first class. Files appearing, ports connecting, timers firing. The kernel already knows. Don't poll, subscribe. 3. Boot time is product UX. 5 seconds versus 30, multiplied by every auto-scale event, is operational velocity you can feel. So here it is. Every directive that matters for sockets and paths on one page. Listen stream and listen datagram for TCP and UDP. Accept toggles between init style and daemon style. Socket user and socket mode lock down the file system endpoint. On the path side, exists, glob, changed, modified. Pick the one that matches your trigger semantics. Unit wires the trigger to the service. Print this. Pin it above your desk. Muscle memory takes 3 or 4 services. After that, you stop looking. Now you put it to work. 3 drills, 30 minutes each. First, build a socket-activated echo server with a templated unit. Feel the flow when NC hits port 12345 and a fresh instance spawns. Second, wire a path unit to a queue directory and learn the hard way why atomic renames or flag files exist. Third, the honest one. Run systemd analyze blame, convert a real service to socket activation, reboot, and measure. Numbers, not vibes. Now the failure modes. 5 of them, each earned the hard way. Enable the socket, never the service, or you've defeated the whole point. Except yes is fine for SSH, lethal for NGINX. Globbing on a write in progress gives you half a CSV and a corrupt database. Forget to inherit listen, FDS, and you'll fight your own bind call. And remember, path exists fires while the file exists, which means stale queues re-trigger across reboots. Memorize the fix column. And that's the advanced stage in the books. Hardening, C groups, sockets, and paths. You're now fluent in the parts of systemd that most engineers never touch. But here's the turn. The next lesson drops the cheerleading. Lesson 11 is when we get honest. The limits, the alternatives, the places where systemd is genuinely the wrong answer. Containers, embedded, BSD, the niche cases, judgment, not zealotry. See you there.